basically initiatives to make a lot of the open source security work that's going on in the India region um, become more popular and get people aware of what's happening in the space in general. We have a very special guest today, and in today's stream, we have a slightly different mode of interacting with you folks, which is that we're having a demo of an open source tool that can help with supply chain security, um, detection and prevention and things like that. Before that, I just wanted to showcase a few quick announcements. So the first one is there's an education survey by the Open SSF. If you're interested in how people should be taught about open source security, and if you're interested in contributing your ideas about how people should learn open source security, then please scan this QR code to make your thoughts known. The next thing I wanted to quickly share is there's a bunch of open source courses which are a part of the Linux Foundation that are available free for you to consume. So if you're interested in learning the basics of security and helping contribute and all of that fun stuff, then I highly recommend checking these out. There's a bunch of different open source projects. So if you're interested, just grab that QR code over there and take a look at the projects that are available and how those can be of help to you. So I'm very happy to introduce today's speaker. I'd love for you to welcome Abhishek. Abhishek is the co-founder of Koala Lab. Do you want to introduce yourself, introduce your work and things like that, Abhishek?
Sure. Thanks. First of all, thanks, Ram, for having me. And as my introduction, my name is Abhishek Anand, and I have worked as a cloud engineering leader throughout my career, more than 10 years now. And I have led platform team at Whitehead Junior. Prior to that, I was CTO at housing.com. And right now, I'm building tools to secure the open source supply chain and secure companies against the various kind of threats. That's the work we are doing at Koala Lab. So, yeah.
So in terms of just work and things like that, what does a typical day for you do? Are you like, every time somebody says security and securing infrastructure, it's got this very fancy stereotype. So I just wanted to understand a little bit about what a typical day for you is like at Koala Lab.
Yeah. So, see, the first thing about security, I believe, is like staying up to date. Whatever you knew yesterday can be completely irrelevant. The system with zero CVs became like full of backdoors just after the exit bug was announced. So, with that in mind, normally I try to keep myself up to date with whatever is there in security. LinkedIn is helpful in that. There are Slack channels that I'm part of that are helpful in that. For example, even the OpenSSF Slack channel, that's a great source of information. Apart from that, what we do is we try to come up with solutions that help you secure your open source supply chain. And as you know, we primarily focus on the process part of your supply chain, not the composition part. So we try to discover new risks, like the brainstorming sessions happen, and then we try to come up with a solution. How can we make lives of developers easier? How can we make them feel that there is no threat in doing this, like making the whole process of consuming open source software secure by design. That is our motto. That's what we try to achieve every day. And since we are a new small startup, so yeah, most of the time is like work, and we focus on trying to come up with more and more innovative solutions to achieve the same.
So do you take a product or a project based approach, or do you just do some sort of audits and you look at people's current footprint and then you come up with sort of solutions and ways for people to improve? So what's that like, and can you share a little bit of information about that?
So it's a typical early stage startup routine. Like we do have design partners with whom we work so that our product is actually being used in production by someone. And with the help of design partners, we get feedback, we get like We get to know how these tools will be used in production, like what are their implications, are they becoming a friction in the process, how can we get rid of that friction. So we do all those things, and that's how we come up with like next set of ideas, like next frontier, like what more can we achieve with this. And that's how we keep on iterating or improving on our products. And apart from that, as you know, like the like security community as a whole is like collaborative in nature. Everyone comes up with their threat vectors. It's not like they will keep it to themselves, they will share. So we take
Hmm.
inspiration from that, and then yeah, we try to come up with the most innovative solution for that, so that it doesn't hamper the developer productivity. So if you look at any security tool, it needs to be adopted by the developer. Like security team can figure out, detect it, but they have to make it part of the platform for it to be a success. So that's what even we try to achieve. How can we make it a seamless part of the overall HDLC? And that's how we pick our next, like what next. That's the ideology that we follow.
Got it. Got it. I wanted to quickly ask you one more thing. So you mentioned a term called secure by design. Can you, for the benefit of viewers who might not entirely be familiar with the term, can you expand on that a little? What exactly you mean by that, and how do you define that?
Right. So I'll take one example for it. That in itself kind of became an inspiration for like a tool like PINNY that we'll be talking about. So if you look at package managers like Golang's package manager or a pip for Python, so what do they do have is like whenever you install your dependency or add a dependency, and in your development environment, whenever you install them, they will keep a checksum of the installed version, and that only will like on the production you can be rest assured that that version will only be used, right? So
Okay.
these package managers are secure by design. Like Golang will keep a cryptographically secure some checksum of the dependency that you use. So whenever your code goes into production, you can be rest assured like whatever you tested in your development environment is going to run in the production. But that is not true for, let's say, any Docker image or a GitHub, because Docker pulls based on either digests or tags. Tags being the most popular version, like the popular
Mm-hmm.
way to pull a Docker image. But a tag is something that is controlled by the creator of that image, right? Even in case of GitHub Actions, the tag is controlled by the creator of the GitHub action, and that tag can be overwritten. So once that tag is overwritten, you are no longer sure that the version that you tested in your development environment is going to be exactly same as the version that is running in the production, and that creates the dependency confusion. So here we can see that these package managers are not secure by design, right? So what you need to do is like bring these things into the philosophy of developing your tools. So Pinny is a tool that aids you in that. It's not entirely a secure by design product, but it helps you in that journey. Like you can pin your dependencies so that you can be ensured, like you can bring the same paradigms of other package managers to GitHub Actions or Docker files, Docker image references. So that's secure by design for you, like something that doesn't give you a room for error. Like the way it works, the way it integrates in SDLC, it will be secure.
Right. So, what I find interesting about all of my conversations in security is all of these security professionals, they come, they sit with you across the desk and say, well, whatever you're doing is wrong. So, you need to do it differently. So, uh, eh, uh, I think a lot of people might share that sentiment, but uh, it's very difficult for me to wrap my head around. This is we've primarily I'm an application developer. I'm very guilty of not having prioritized security as a thing, from the beginning, and paying attention to that. Obviously, I'm trying to change that habit a little, but there's only so much I can do. I'm entrenched in that app development world that just wants to ship features fast and keep picking away at that backlog, and then every sort of security conversation feels like a speed bump. But I understand where this is coming from, and I'd love to see the tool. Take a look at what it is that you folks have developed, and we can chat a bit more about the things around the tool in a bit. But let's um, let's show folks what you have.
Uh, sure. Just let me grab the
Sure.
browser and then we can start. Yeah. So, uh, is my screen visible?
Yeah, absolutely. Yeah, go for it.
Yep. So this is the tool that helps you pin your dependencies into of GitHub Actions and Docker images by their respective hashes. Like mostly it's Shaman hash for all these things. So apart from doing that, PINNY, we recently added another feature to PINNY that is called uh, uh, checking of imposter commits or imposter references in terms of GitHub Actions. I'll expand that in a bit, but let's first deep dive into the usage, or I'll just give you a brief demo of this. Right. So let's first install it. Yeah. So yeah. So now I have Pinny and I can validate. Yeah, I have the Pinny's latest version running over here. And if you look at this repository, yeah, this is a standard repository that anyone can use. So here, what I have done is like you can see these. This one is a version that is hash pinned, right? The GitHub action that this is another action by Koala Lab, and
Okay.
we will talk about it sometime later maybe. So this is pinned with its hash. But if you look at this particular action setup node, it is
Hmm.
not pinned. So similarly in other workflows, we can see that even the bolt that one was pinned is not pinned over here.
Mm-hmm.
Yeah. So now, what Penny does for you is like you simply go do Penny actions and pin. So it will start parsing your workflow files and will look for actions. Actions those are not pinned, and if, these are interesting warning messages that Penny is telling us. I'll come to that. But Penny has finished working now. If I look at git diff, I'll see that so the whatever was v4, it has been pinned to its respective hash. Over here also you can see it has been pinned to its respective hash, right? So yeah, so the Penny's work is done. But now coming back to the warning messages that we saw. So Penny didn't find for a exact reference match for this. So this can happen when, let's say, you were using a hash reference and the tag corresponding to that has been updated now. So you will no longer find this hash corresponding to any tags. So this is a warning. This can either reflect that the tag has moved. For example, if you are using a alias tag like a v3 instead of a fully qualified tag like v3.1.1. So this can happen. This can very well happen. But the next one is pretty interesting. It is imposter. We have found an imposter commit over here. So what that is, I will quickly show you. So if I curl over here, so if you will see, I have copied that commit only. Yes, if I run it, I'll get that. Yeah, this commit is there. Its HTML URL is there. Now let's go to this HTML URL. See this message. This commit does not belong to any branch on this repository. and may belong to a fork outside the repository, right? And given I have created this test case, I know where this is. But if you look at the response, you will see nowhere the reference to the actual repository from which this commit is coming, right?
Mm-hmm.
And I know, so I'll go and check in that repository. It's my personal account. So see, from here this commit is coming. Okay.
Okay.
So let's go to this commit. So this is a fork of that. You can see fork from Koala Lab Inc. But the interesting thing is to look for here is, even though this commit was not there uh, in the in my Koala Lab Inc. / Bolt repositories, I can reference it and fetch that code. What this means is anything that I commit in my fork will be referenced there in the name of Koala Lab Inc.'s
Mm-hmm.
Bolt repository. So what this does is like once, let's say what I'll do is I'll quickly show you how can it harm me, right?
Okay.
So let's say I create a README for Bolt or I write some kind of blog for Bolt, and I'll just say just add these two lines to secure your GitHub actions. Now this here is an imposter commit. This is not by Koala Lab, but I came across it on a blog or something. So I will just try it out and we'll see. So
Okay.
right. So what will happen from it is, yeah, see this. I'm checking the same. So, like I have added, like I have done some changes. I have added this caution message in the summary generated by this action. And there I have written like, you are at risk, you are using an imposter commit reference of Bolt, and this is not there in the parent directory. So,
Mm-hmm.
so even with any kind of like by looking at this, you cannot say that this is there or not. But PINNY, whenever it comes across at already pinned hash or already pinned action, it will go and cross check that whether this commit exists in your GitHub repository or not. And using that, I was able to show you this message. I again go back to that this imposter has been found over here. So this is a
Okay.
big risk that you should be aware of. Like whenever you pin your actions, uh, this can happen, right? So once again, let's check the diff. So as you can see, PINNY has pinned all the actions that were there in across all the workflows, right? And
Mm-hmm.
mm, now let's see the Docker file. So this is the Docker file. I'm using no tags. That means the latest. And I will ask PINNY to pin it as well. The -i flag is for like pinning it in place, or I can just remove that so that I will have this file. So now it will generate a docker file dot pin. So now if you look at it, it has pinned it with the SHA 256 hash of that particular docker. So now even if the developer of this particular image pushes a new version of the image on the same tag, because latest
Mm-hmm.
will always keep on updating. So then you will be vulnerable. And see, at times a malicious actor can take advantage of it, but that is a like a threat actor acting against you or trying to compromise you. But there can be unintentional security issues as well. So what I mean by that is, let's say a developer is, let's say developer is pushing a new change, updated its latest tag, and their new security vulnerabilities came in that as a consequence of just the update or the new code. It was not properly scanned, not went through the proper rigor that is needed for you to consume it. So there unintentionally a security vulnerability will reach your production system just because you have not pinned it to a version that you can trust or that you know of, right? So that is another case. Then there are use cases of like I will just pin it at in place so that I can show you the diff as well. Yeah. So the same thing in a diff version is there. Pinny also allows you to sorry, like lock your Docker image references. This we have done keeping in mind that you might be using one Docker reference, and then you another added reference to that in another file. Let's say another Docker file. You want all of them to be in sync. So for that, you can simply generate a log file. I'll show you how you can do that. Yeah. So what we saw was a pin command. There is a log command that generates a log file, and then you can simply use a transform, which like just reads the log file and transforms any Docker file that you provide to it. So this helps you keep the version across all the Docker files or all the references to Docker images in your repository in sync. So yeah, I guess that's the tool in action. We can see. So yeah. So yeah, over here also you can see similar examples like a pinned Docker file here. This was pinned like this, and a pinned GitHub action workflow which is pinned like this. So this like pinning, basically now let's talk about what it secures you against. It secures you against dependency confusion that I talked about right away, right now. That when it in dependency confusion, what happens is the tag that you intend to use is not pointing to the exact version. Like someone can push a different version behind it after you have started using that tag. So that is number one. And then there is the other thing that I talked about, that was imposter commit. So that is number two, like where a commit that you are referencing is not even part of the project that you are trying to use. Then comes the part like repo jacking, which is a big issue where like repository which used to exist or like what people do is like once something is deleted, they try to take over that repository by creating something in the same name or something like that.
Right.
Like GitHub has a graveyarding process or something like that, that it puts some names to like adds it to its graveyard that no one can use it again. But that is not really possible to use it across all, because then soon we will run out of all meaningful names, right?
Right.
So,
Right.
right, so GitHub, their GitHub can't help. So that is why what happens is like attackers, they some like if some repo is, let's say, stale or is deleted, they will create something by a similar name or same name, and will that is called as repo jacking. And then if you are not using a tag reference, sorry, a pinned reference, so the attacker can upload or can push a change on the tag that you were using, and now your action references are now pointing to a different repository altogether. So
Right.
this attack is called you can say repo jacking, which has become a serious concern. Like Aqua Security did a thorough research on it and found that like people are programmatically creating hundreds, not just hundreds, thousands and 100,000 repositories, and GitHub is actively deleting it. Still, there are few like tens of thousands of repository which can be like which you can say are repo jacking attempts that are out there on GitHub live. So
Right.
yeah, you need to be really, really careful about what you are using. Yeah. So, so we have some docs as well here. These have like for the imposter commits or secure by design OSS. So these docs take you through more or less the same things that I talked about. There are other risks as well when the dependencies are like dependency or dependency reference is concerned. But PINNY at the moment doesn't cater to that. There are we have like other offerings like the other tool that we saw, which do help you in becoming secure by design. The Bolt that we saw in
Yeah.
action. Yeah. So other things like typo squatting is there, where like people are slightly changing their repository name, or
Yeah.
like they will make Java Maven to Maven Java or something like that. uh, you will just go and reference it, and you will fall prey to, let's say, typo spotting. Similarly, brand jacking is there, like companies similar sounding name like Koala Lab Inc. is there. Someone can go and create Koala Lab Com, right?
Yep.
And you will feel that okay, it's koalalab.com's GitHub repo only, but no, it will be something else entirely. And similarly, like there is GitHub, there can be Git hyphen hub. So yeah, need to be careful about that. And like, and the last of the dependency related issues is like dependency hijacking itself, where like attackers by let's say by compromising the processes itself, like where you don't have good branch protection rules, or you don't have proper contributors screening process, they hijack the repositories. At times, these attacks can be extremely sophisticated in nature, like the ones we recently see in the case of XZ, where the attacker took almost 2 years to make themselves the maintainer of the project, and
Right.
then they injected a backdoor.
Right.
And to like there can be many such ways in which the attackers can try to gain access to your production system or your build system. So the real way to go about is I'll say twofold. First, make your infrastructure secure by design. Even if something bad reaches, like you are looking at the right matrix, you are looking at the, let's say, the audit information. You are looking at the egress information, like whatever egress calls are going, whatever processes are being spin up, whatever are they tampering with my source code file, source code tampering. So these are the things that you can like you should monitor during your build in your build environment. That makes it secure by design. Like let's say it's a tampering of source code is a that is a build environment threat vector. Like that happened to solar winds, right?
Yeah.
But if
Yeah.
you're monitoring your build, if you're monitoring your source file during your build, you will be alerted the moment such an attack vector enters your system, right? And
Hmm.
then you can trace back to it like I should not be changing this file during my build time. So what is happening? You will go investigate. So even if something bad happens, you are secure by design itself, right? Same stands true for egress filtering as well. So if you are looking at the your egress traffic, and suddenly you started seeing traffic to a domain that is not expected by default, so you will investigate further, and you can altogether audit it, make a whitelist and block the egress to others, so that such calls don't even need to do anything, right? And yeah, and last piece, I guess, to prevent any kind of build environment, I will say is observability. You observe matrices. The performance matrices also matter. You go and you check, like whatever used to take say X amount of time certainly started taking 1.2x, 1.3x. Like if you look at even the XZ attack, it was surfaced because of that. One developer, he was very attentive to the performance metrics, and
Mm-hmm.
like he saw that the SSH time like went up from 500 ms to 700 ms. So where
Right.
the extra 500 ms came from? We started digging, and as a result, the I will say the whole world was saved. Like right, I know of my friends in security that they had sleepless weekends, like patching for the XZ attack, and there are many
Uh,
attacks lying out there undetected, and the best way to like ensure that you are protected against them is make your environment secure by design. Yeah.
Interesting.
So
Yeah. So this tool, it looks like something that can be applied to Docker files and GitHub Actions files and things like that. Are there other um, sort of declarative files, I guess, that it can be applied to as well, in addition to these.
See, in the beginning itself, I said that Penny addresses a gap that is there in the nature of the way the product, like the package managers for Docker or GitHub Actions function, right? It is filling a gap over there. So in case of, let's say, Golang or your Python packages, you can have static analysis rules to ensure that you are pinning your dependencies. For example, if you are running a pip install, you save that, save the dependencies or save the hashes and commit them. And in your code, like you can have a static analysis that I should always do pip install on my CI system, referencing those hashes, right? So that makes itself secure by design. So I'll say Penny addresses that for GitHub Actions and Docker images. And as you can see, we like as in when we find new threat vectors like this imposter commit one, we address that, and we will keep on addressing more. And we are if you see the future of Penny, we will start supporting more and more such systems. For example, this is GitHub Action. It can be in context of, let's say, GitLab as well, or it can be in context of some other build tool, because such references are mostly found there. And the other is like supporting more types of file. Right now, we support GitHub Actions and and by GitHub Action I mean GitHub workflow files. We find
Sure.
actions in them and pin them. And the second one is Docker images. Right now we are supporting parsing of only Docker files.
Okay.
We plan to extend it to, let's say, Kubernetes manifests or your Docker compose files or
Hmm.
any kind of file that references Docker images.
Right.
Uh, yeah, we plan to extend it to that.
Interesting. And in terms of applying this itself, so is this something that you imagine will be part of every developer's workflow, or do you think that it'll be part of like a platform of sorts that people will expect to use? How do you imagine that developers will start using this more and more?
Right. So the way I see it happening is like I will make my build environment secure by design. Let's say by that in this context I mean the other action that we came across, Bolt. So we are going to release a functionality in Bolt that will just check whether your actions are pinned or not. And if the actions are not pinned or Docker images are not pinned, it will fail the workflow or it will alert you that this is not pinned, right? So that in conjunction with pinning on developer machines, like developers pinning their dependencies using Pinny and Bolt in action on your bolts this particular features in action in your CI environment. This in conjunction can ensure that all your references are pinned, and if they are not pinned, it will not run in production or in your build environment.
So you expect that people will use this along with their current workflows where they do some admission control and things like that. And so, in the absence of pins and in the absence of these,
Yeah.
um, um, in the absence of that metadata, essentially, then things should not be allowed to be deployed and things like that. Um, when you describe this, I'm starting to draw a parallel between signatures that we've been hearing a lot about. Um, I'm sure you're familiar with like the SIG store and the cosign and the uh, open pub key project and all of these things. And so I'm trying to draw a distinction between what exactly you're trying to achieve with this versus what are they trying to do, and is there an overlap, or are these two completely different things that I'm just becoming confused about? Can you clarify that for me?
Right. So, see, what we are, you can think of these references or tags as a pointer to the dependency that you are trying to use, right?
Hmm.
even the name of the repository or the name of the brand or the organization is a pointer to that. So what happens is the attack vector that we are dealing with is primarily around attackers trying to manipulate the pointer, right?
Okay.
Whereas like Sigstore projects like Sigstore and like other like Cosine, what they are trying to achieve is like creating an attestation of your build process. Like whatever is your build process, it will be its attestation will be generated. You will sign your builds and you will publish to the world that see this is my signed build. You can see this is the process that I used to make it, right? This is more like a like these tools help you achieve the salsa attestation, for example. So
Yeah.
you uh, tell it to the world, see, this is how I built this, and this is the proof of that. You can go reproduce this build and check for yourself that, yeah, I'm doing what I'm like claiming to be doing, right? So
Mhm.
that is more around establishing trust and means there can be verifiers of sort like who can go on and verify it and they can be a trusted party to verify those signatures, right? Or try to run those reproducible builds uh, and reproduce the builds actually and verify whether the builds that you are pointing to are actually produced via the said process. And with the help of trusted platforms like GitHub, where like the workflows, what workflow was run is being guaranteed by GitHub itself. Like
Okay.
GitHub has that functionality where it like seamlessly integrates with Cosine and all. Like there are GitHub action for that as well, where you will have reference to the GitHub workflow itself that ran. You will have reference to the workflow run, the run logs. You can go and check over there if required. Otherwise, that attestation you cannot generate that without GitHub, without actually running it on GitHub, right? Because
Okay.
it needs the ID token permission from that repository. So that way, those are more around the attestation of your build system itself or the build process, right?
Hmm.
And they also encompass things like whether you had a approval mechanism in place in your repository or not, and GitHub helps you like incorporate all those in your build attestations. Basically, what Pinny is trying to solve is an entirely different problem, where like
Okay.
attackers are trying to manipulate the pointer, the way you are trying to get your repository. They are trying to trick you into fetching something else that you are not intending.
Nice. Um, but thanks for clarifying that. um, so I also wanted to chat about a little bit about um, what's the current status of this tool. And I know you mentioned you're trying to build a few features into it, but in general, what are your like visions for this particular project? Do you imagine using it in all of the security work that you do? Do you want to see more people use it independently? What are your goals
Right.
there?
So what we want is to like I'll go back slightly where you mentioned that as a developer you try to stick to security practices as much as,
Hmm.
but you feel you still are not there in the eyes of security teams, right? But my take on that is it's the onus of the security, like the security community or uh, the developers or the organization in this in this community to come up with tools that developers love to use that seamlessly integrate with their workflow, right? So when we launched Pinny, we had this learning that it is something that you want to use on your like if you really care for pinning your dependencies, you can use it. It's more like a helper tool. You know what to do. Instead of going and doing it one by one, it will pin all the dependencies in one go in your repository, right? So the next iteration I'll say will be to creating a secure process around it, and where like the complementary action, the complementary feature of action bolt by Colala will come into picture, where you will be able to like fail the check or maybe raise an alert as soon as a workflow is run with, like, let's say, direct reference instead of a hash reference to a GitHub action. So that is where we see, like, the adoption, where there is a maker checker kind of thing where
Mm-hmm.
developers uh, incentivized, or you can say push towards adopting it. So that is the direction we think it will take, and that will give us a push to Pinny adoption of Pinny as well. You can see it like an analogy to it is like a SaaS tool. Let's say if a SaaS tool, like if you do something that doesn't align to the SaaS security policies, it will fail the workflow, it will fail a check, and you can no longer continue with your merge process. So,
Mm.
right, so in order for you to continue, you have to go and fix it. So over there, if you look at the evolution, what people are expecting out of SaaS tools, or developers are expecting out of SaaS tools, is like there should be a mechanism to auto fix many things. But most of the things can be fixed, right? The like it will be like, don't do it like this, change it slightly. So it's there. What you have to do is there in the recommendation itself. Just that it's not being done, and there are hundreds of them. So uh, I will say the SaaS industry is moving in that direction where they want it to happen auto fix. Similarly, Pinny will help you do that. Like it will auto pin all your dependencies so that you don't have to. And yeah,
Mm-hmm.
it will seamlessly then integrate. If you want to use it, like let's say as a pre-commit hook, for example, you can use it.
Okay. And so, in your opinion, what are commonly the points of friction, or where are you seeing the most inertia from developers when they're shown a tool like this and there's a recommendation that you have to use this, and where do you see them, where do you see tool or technologies or security professionals struggling the most in order to convince developers to pick up tools like these and incorporate them into everyday processes?
Right. So, first of all, it should integrate seamlessly in the whole journey. Like, it should not be like the feedback mechanism is such that something is leaking to production. So, for adoption of any security tool, a gate is necessary where like security team can be on top of it. It can either be in an audit kind of mode where you get to know if something bad happens, or it can be in a enforce mode where like if it happens, it won't let you move in it. Having said that, I guess every security tool should be mindful of like the developer time that they are demanding, right? Developers are anyways constrained about the time they have. They are always deadlines to chase. So any tool should be really conscious about the amount of time that they are going to consume, and our motto is that only that build tools that integrate so seamlessly that they won't take any of the developers' time, and still you get the same level of assurance in terms of security that you would have otherwise, like that you would have, let's say, by making training the developers or making them conscious about security. What if your whole process is around that, so that all they have to do is like just like over here, just run Pinny or just add Pinny to their pre-commit hook, and they're taken care of.
Hmm. So you do have other tools. I think we're scheduled to speak about Bolt uh,
Yes.
sometime later next month, if I'm not wrong.
Right, right. Definitely, I'm looking forward to that. And Bolt is a broader offering that gives you many more capabilities. And as I said, one of its features is to like seamlessly complement Pinny in the way that if you want to, let's say, audit your workflows for being hash pinned or your Docker files for being hash pinned, that's more like checking them at the build time whether they are adhering to the uh, adhering to your rules or not, right? Similarly, other offerings that we are building or we have built is around observability of your CI/CD environment, which I guess is uh, apart from being like other tooling like egress and audit of your build environment. The observability is a piece that we think can be really powerful in the sense, if I draw a parallel from this XZ attack itself, if there was a tool that was constantly monitoring all your matrices in your say build environment, and if there is a drift, it tries to correlate with what changes are pushing it, like what can be the root cause of this particular change in this matrix, and if there is something that needs to be further investigated, you just receive alert for which you can do the investigation. So things like that, being on top of your metrics, will really go a long way in like early detection of if something is going wrong. So I guess security world of today has accepted that breaches will happen, right?
Yep. Yeah. Absolutely.
So how to minimize the impact of that and how to get to know about it as at the earliest. That's the two goals that the whole industry is targeting.
Fantastic. Thanks, Abhishek, for spending your valuable time, especially at the back of such a major uh, vulnerability being exposed last week, and the whole world scrambling around it and trying to figure ways to uh, cut people's losses, mitigate future attacks, and things like that. I'm sure a lot of the people watching this will find Pinny very helpful, and hopefully there's some awareness that we can build through programs like these. Just a reminder to folks, there's going to be a bunch of other similar sessions hosted by the OpenSSF virtually. There's also a SOS Community Day, so Secure Open Source Software Community Day, that's happening in Seattle, hosted by the OpenSSF on the 15th of April, few days from now. So if you're interested, if you're in security, or if you're in the Seattle area, you want to learn more about it, I highly recommend attending that. There's also going to be a bunch of other events that are sponsored, hosted, etc., by the OpenSSF in different parts of the world in the coming year. So, if security be your jam, I highly recommend um, attending one of these and interacting with our community there. So watch out the same space for more announcement about events to come. Like I said, we have Abhishek once again with us in May to showcase Bolt, and we will also have some other showcases during the month of May. So check us out on openssf.org/events for the event specifically, and openssf.org for the project itself. But yeah, before we close, thank you so much, Abhishek. Like I said, it was very interesting to watch the tool, and I'm sure a lot of developers will find some benefit in making use of it. And hopefully, the community around Pinny grows, and we continue to make a lot of important open source contributions to the security space.
Certainly, Ram, and thanks a lot for having me and giving me this opportunity to present Pinny to the world. And hope the community finds some value in it and open for any kind of like issues or feature request around it. Like, looking forward to growing it together with the community. And yeah, speak to you soon.
Yeah, thanks. Bye bye.
Okay.